competition in Black Rock. So I thought I'd come by and tell you a little bit about what we're doing and offer to collaborate in things that we do really well. We host the ARLISS project, a rocket launch for International Student Satellites. We are a California nonprofit educational corporation. Our long name is the Association of Experimental Rocketry of the Pacific, and we are probably the oldest amateur rocket club in the United States. We started operating in 1985, certainly operating in Black Rock, and we are affiliated with the International Tripoli Rocketry Association. As you know, ARLISS is all about students building, launching, and flying sophisticated little small satellites to suborbital space. And traditionally, we've done that to about 3 kilometers. As you'll see here, we're now extending that up to about 30, maybe to 80 kilometers. The key thing is we integrates the head and the heart and the hands by being able to do everything as practically together. And this competition is in principle open to everyone from middle school students to high school students to university students. And we have the benefit of a superb location in Black Rock, Nevada. I'll talk a little bit about that. This is the 60th, we've done this now for 16 years. This will be the 17th year coming up of ARLISS. So I want to extend a thank you. We've had great fun. We look forward to doing more of it. It was started by my mentor, Bob Twiggs. If you haven't met him, he's a wild and crazy guy. And Shinichi-san here. Is a unique partnership in the sense that our members of our club are very experienced rocketeers, and they fly the rockets. You'll see that we have an astonishing success record, 99.8% success on deployment over 600 missions. In combination with students doing very innovative projects. We've now hosted students from over 17 countries, including China, Colombia, Costa Rica, the Czech Republic, Egypt, France, Greece, Hungary, India, Japan, Norway, Peru, South Korea, Taiwan, Turkey, as well as the United States. And if we haven't missed a few, we invite you all to come out. As I said, we've lost count, actually, the exact number, but we know it's over 600. We've lost 2 student satellites in those missions, over 600, so we're kind of proud that it's at least 99.8% successful on deploying missions. And we, by our guess, about 2,000 students have come by through the program. We possess a very unique location, the Black Rock Desert in northern Nevada. It's at about 1,200 feet base elevation. We negotiate with the Bureau of Land Management and the Federal Aviation Administration for a flight operations cylinder that goes 60 kilometers high and about 60 kilometers in diameter, and which we can fly just about anything we want. We can actually go higher. There have been space launches out of this location. It's about 2,000 square kilometers of dry lake bed. It's hot, dry, rugged, and really remote until recently we brought in a satellite dish to do remote Wi-Fi. And it's perfect, essentially, for rockets and robots. ARLISS has now grown into a family of programs. You probably know about ARLISS Classic, which is where we fly a 6-inch diameter airframe with a 1 kilogram autonomous satellite, and we deploy it. We throw it out the door at about 3 kilometers high and has to find its way home. We've now expanded that to what we call ARLISS Extreme, which I'll talk a little bit about, which is now where we can take CanSat or pocket cube size payloads up to north of 35 kilometers, fully recovered and reusable. And lastly, we're working on something domestically I'd be happy to talk about more. I'm not going to talk about it in this talk, called ARLISS S4, which is small satellites for secondary students. You should think about them as internet CanSats, so an integration of Arduinos, TCP/IP, Wi-Fi for telemetry. So essentially what we're looking at is integration of doing payloads in the sky that are essentially making rockets into an Internet of Things. We're pretty excited about this. We're doing this with Sonoma State University, with NASA, and the National Association of Rocketry. The ARLISS Classic mission profile is where one of our members flies an airframe up to 3 kilometers. We throw out the student satellite. It then has to find its way home at 3 to 4 kilometers high, and it has to fly, crawl, glide. The key thing is the recovery of the mission, not so much the way you do it. And it's a relatively modest cost. Since we're a nonprofit and our members do this because we love it, we basically do it for the cost, which is the cost of the propellant, which is about $400 per flight.
4, 3, 2, 1. As we stop there.
So we do about 50 of these flights per ARLISS these days. This guy was very cute. Struggled very hard. Thinking about it. And just when despair occurs, and as I recall, this particular, you're going to see now, I think this guy had to crawl back about 4 kilometers across the desert. So. It's lonely out there all by yourself. Now this turns out to have been a year, 2006, was relatively dry and flat. You can see the ruts there from truck ruts. They're relatively not deep. Sometimes they're 6 inches deep, and trying to make your little robot go back through them is hard. The flag is the goal, closest to the goal. Look at that turn.
It's coming. Hey, hey. みんな集まれ。ほら、A チーム集まれ。Oh! Stop.
So across a few kilometers and a few kilometers up and a few kilometers over. Not bad. Very good job. Now, this is a couple of pictures of teams and kind of their projects. You can see the size of the rockets. They're about 7 foot tall and 6 inches in diameter. We fly them on a constant M-size motor of about. This is now ARLISS Extreme. You can see it over here on the right, about 10 feet tall. We won the prize in 2012 for the first documented amateur flight above 100,000 feet. We got to 104,000 feet, which was actually low because we actually lost our front launch lug on launch. So in fact, it went 20 kilometers up, 20 kilometers up and 20 kilometers over. So a little, but it was the first documented amateur flight. We can now fly payload missions to about 35 to 80 kilometers in the basic airframe, which is about, will take essentially a standard CanSat or a 2P pocket cube. It's a 2-stage fiberglass airframe with commercial solid rocket motors. It's fully recovered and reusable. And we're still test flying it this year. We'll fly another 3 times this year. We flew once 2 weeks ago. And we'll be flying operationally, looking for payloads for any of you folks that want to come out and fly to have a payload to go to the edge of space in 2016. It's relatively low cost for what we do. It's $2,000 a flight, which again is basically the cost of the propellant. This is a little bit about the flight in 2012. This is the video off the airframe. see we're tilted. We're not exactly going to the zenith. This is staging. You can see the cameras are now separating, going in opposite, spinning in opposite directions. You can see the playa below us. And we're about to make that transition from blue sky to black sky. And you're about to go past the tropopause, and all the sound goes away. Here we are passing, getting very close to Apogee. Sadly, we're still going a fair amount of speed horizontally. But here we are, just kind of lazing around, 1,000 feet per second at 104,000 feet. Deployment of the drogue. I took out the 10 minutes of coming down, and here's where it came down. That was the site at Apogee. Not bad. This airframe, since it was the first amateur flight above 100,000 feet, is now the centerpiece of an exhibit at the Seattle Museum of Flight, which is the first amateur rocketry exhibit I'm aware of in the world. So our airframe is right there. So Airpack, we do flight operations at Black Rock. We have, on average, about 12 flying days a year. We go out 3 times a season, which is generally through June through September. We have a dedicated team. We have membership of about 200, and we have a dedicated team of about 20 people that are kind of like me that teach other people about rocketry. As I said, for ARLISS, we have about 99.8% reliability in deploying projects, and we handle all the regulatory and safety management with the various agencies. We've now added a virtual classroom, which is actually Bob Twiggs' inspiration, is a donated van that has a satellite backup internet that does Wi-Fi and telemetry and more radios than you kind of even I know what to do with. And we now have added this really kind of astonishing, we call it the Uber rail. It's actually a computer-controlled, Wi-Fi controlled, stepper motor controlled rail that we can point within about a quarter degree in any direction. And it's actually kind of amazing because if you ever see Top Fuel dragsters, it was made by guys that made Top Fuel dragsters, so it's chrome moly steel. It's quite stiff and quite amazing. This will be the 17th year of ARLISS Classic, and we really look forward to having the ARLISS teams coming back in September. We'll have a fully operational ARLISS Extreme starting next year. We've got 2 more flights, I said, that we'll be doing this year as test flights. And we're going to have about a capacity for about 10 to 20 ARLISS Extreme flights per year, depending on demand. And we believe the basic airframe, by just putting a bigger motor in, will take us to 80 kilometers. It turns out in the regulatory scheme in the US, because the motor size is still actually a model rocket under US definitions, we don't require explicit FAA permission. It's kind of an interesting gap in the law. We're now experimenting with, my background is in as one of the inventors of Wi-Fi. I'm very interested in using Wi-Fi for telemetry. So this is a lovely little $200 tracking dish that should go out to about 200 kilometers, we think. So we're looking to instrument with high-speed telemetry using essentially commercial off-the-shelf radio electronics that go much faster and much higher than the conventional ham radio kind of things we've used in the past. And lastly, I'd like to extend an invitation to come join us. Come out and fly either ARLISS payloads with ARLISS Classic or ARLISS Extreme. Come talk to us about rockets at Black Rock. One of our jobs is we mentor people to build better rockets. One of the things I love to do in my evening job. Collaborate on any of these high bandwidth telemetry things. I think it's intriguing. I'm rather appalled about the status of communications in rocketry, and I'd like to make it better. I build large telecommunications networks on the Earth. We can do much better in space and in the sky. And lastly, collaborate with us on CANSAT projects. We've now extended ARLISS into Costa Rica and I believe Peru. We'd like to help more. So, thank you. Any questions? Thank you.
I heard that Boston University is very
I have had some contact with that team. I'm a little skeptical, be frank, because they've never flown that rocket. I think that it's very tough to do a first-time flight, and so we'll see. I wish them good luck. They're going to fly in July, I believe, and we'll see how they work. But I think it's challenging. Well, they have no experience. You know, basically, they've made this rocket, been working on it for a number of years. I think they wanted to take other payloads on it, but I think that they haven't flown it, right? So I think that when they have an experience flying, they'll know more. We have not. You know, when we're going to 3 kilometers for ARLISS, you know, that's kind of a different project. We're looking for educational focus. But frankly, when we start looking at ARLISS Extreme, you can almost begin to do real science when you get above 35 kilometers. You know, you can actually do gamma ray astronomy at that altitude. Yes, we'd love to. Good. Thank you.
So we will come back here 10:20, I think. Yep, 10:20 for the second sessions for the group discussions. So please enjoy a tea break and coffees.